Hi, my name is Anna Blumenthal, and this is Project 1 for ME 3210 Design and Manufacturing. My project is called the Guillotine Paper Cutter Design Improvement, and the description of this project is to design improvements for a widely used product based on the design factors listed below, which are ease of use, human factors, and ergonomics. And designing for ease of use means to kind of design to have a straightforward product that users can look at and understand how to use without it being overcomplicated. Designing for human factors is seeing how intuitive a product is for somebody and understanding if this is a product that people need and that people can use. And designing for ergonomics, which I think my improvements mostly focus on, is the need to design a product to focus on efficiency and effectivity for its users, and this has an emphasis on the safety of a product for the consumer. And so my selected product is the Guillotine Paper Cutter, which can be seen in this image here. It's used to align paper with the back parallel support, and then you can slide it through the safety rail and slice it with the blade attached to the side, which I will explain more in the next slide. So here is a video of the functionality of the Guillotine Paper Cutter. So you can insert your paper, align it with the back, and then support it with one hand and chop with the other. And so that's how it works, and they can be made with various materials. Some use wood, some are more plastic based, and there's a range in quality for the product. So my product improvement idea is to modify the blade attachment system so it has the capability to attach the blade to the left or right side of the cutting board. And I picked this because I'm a left-handed individual, and I have friends and family who are as well, and it's a very solid amount of the population. And there's a various amount of products that aren't designed for left-hand users, including the Guillotine Paper Cutter. And so the side of the cutting board that the blade is located reflects which arm is used for the cutting paper. Since this type of paper cutter is designed for right-handed users, and the variations I found were also designed for right-handed users, the blade is always on the right side of the board, which means that you always chop with that right hand. And so for left-handed users, this poses a challenge to utilize a potentially dangerous product without being able to use the more comfortable hand. And so it's a safety risk because you're using a product in a way that doesn't feel natural for some of the consumers. And so my design idea will make the Guillotine Paper Cutter ambidextrous, which means that it'll be symmetric on both sides, and the blade can move so it can be mounted on the left or right side, so you can use either hand to use this product. Here's the modified design I made using SolidWorks of the Guillotine Paper Cutter. This is the right hand orientation, but the main feature I'm going to be focusing on is the threaded knob that I added that connects to the blade and then attaches into the cutting board. There is a hole on the other side of the cutting board that allows for the blade to be mounted using this knob on the other side. And so, as you can see, there's protected rails on both sides, and it's a symmetrical design. Here's the left side orientation. As you can see with this, there's a hole that allows for the threaded knob to be screwed in by hand on the other side, which means that you can remove the knob and move the blade over to reflect which side of the board you would like to use, which means that users can adjust the board so it's more comfortable for them. Here's the exploded view of my assembly. So the threaded knob has tight clearances for length of the non-threaded part of the screw to allow for a tight blade fit, and the knob on the screw has dimensions to accommodate for adjusting by hand. So this is large enough to adjust just by twisting with your hand. So this is a design factor I chose for ease of use. So you can use it without needing to use an external tool to unscrew the blade. And so the holes are drilled on both sides of the paper cutter as well. Here are the drawings I made, with the left one being the left paper cutter assembly and the right being the right paper cutter. And as you can see, the blade moves, so it still has that freedom of rotation like the typical paper cutter does. Here's the threaded knob design. As I mentioned before, the knob is over an inch tall, which means that you can adjust it using your hand, and so it's threaded, meaning that you can just tighten it and loosen it from the cutting board itself without having to use a screwdriver or anything like that. So it's simple to use, but also has thread, so it should maintain in place. So a couple advantages for this product is that it is designed for ergonomics, because design allows for left-handed users to use the product in a safer manner. So having the ability to use the blade with your dominant arm allows for more control when using this product. Design is more user-friendly because it accommodates for left-handed and right-handed people, so that's a design for human factors quality. And it is more flexible to use for various applications, so you can, even if you're right-handed, you can use it for either side if that is what is beneficial for whatever project you're working on. A couple disadvantages is because the knob disconnects from the board, it means that you're handling more parts, a part can get lost, and also this could pose as a potential safety threat because the blade can disconnect. So a potential solution is to design a shield that would disconnect with the blade when you move it over. So there's a solution to this potential problem. Here are the manufacturing processes for the screw, which is the major feature on this assembly. So thread rolling uses the reciprocating die, which can be shown with this image right here, or cylindrical threading. So what I researched, reciprocating die is what's used most commonly, and that applies a pressure to create the threads. And to create the knob, if the knob is made out of plastic, you could use injection molding. The material selection for the threaded knob, you can use nylon or stainless steel. I leaned more towards stainless steel with the model I created because the thread stripping in this application is less likely than with a plastic material, but it has a higher cost than plastic. So according to this chart, they both have high impact resistance, so they're both positive materials to use for a knob, according to my research. So they are both good options, but because of the potential of the threads being stripped, I chose stainless steel as my material. I would like to disclose that this design was produced for educational purposes only and based on the current knowledge learned from design and manufacturing thus far in the semester. And here are my works cited, including articles about manufacturing methods, materials, and also surveys about left-handed users and products that they thought should be improved upon, just so I had a better idea of the general population. Thank you for your time.